Okay, so let's look at the graphs of absolute value functions. We're going to use this basic form of the equation. And if you'll notice, with the exception of the absolute value bars, this looks like the modified point slope form that we used when we were graphing linear functions. And when that would happen, we would take h and k, and that would be a point on the line. And then we would use our slope to find more points. Well, this time, since this is an absolute value function, h and k is still going to be a point on our graph. Remember to always do the opposite here and the same here. So our vertex point is going to be h and k. The a that's on the outside of the function, this is going to tell us which direction the graph points. Now, since the absolute value is a V-shaped graph, if a is greater than 0, that means a is positive, then our V is going to point up. If a is less than 0, that means that it's negative, then our V is going to point down. Okay, so looking at our first graph here, we have f of x equals 2, so my a is 2. And then I have the absolute value of x plus 1 minus 3. My vertex point is going to be h and k. So since I have x plus 1, that means my h is negative 1. And then k is negative 3. Remember, always the opposite for h, the same for k. So with this being my vertex point, I'll go to the coordinate plane and I'll go to negative 1 on the x and negative 3 on the y, and that's my vertex point. Now, to get some more points, we're going to use our a. Since a is positive, that lets me know that my v will open up. So from the vertex point, I can go up 2 to the right 1, and that'll be my next point. Up 2 to the right 1. Now, because this is a V-shaped graph, everything will reflect to the other side. So I can also go up 2 to the left 1, up 2 to the left 1. And this will be my V-shaped graph. And of course, this will always work as long as there's not a number multiplied to x on the inside. Okay, so the next thing that we want to talk about is the domain of this function. Now, when you're dealing with absolute value, you can plug in any x value. It's your y value that's going to be restricted. So if you look at the graph, you can see that we're able to use all the x values. So the domain of this function is all real numbers. Now, the range is a different story. If you'll notice down here at my vertex point, that's the lowest part of the graph. So we're starting at negative 3 and going up. So my range is y, since we're going up, is greater than or equal to negative 3. Now, another important part of the absolute value function is the axis of symmetry. The axis of symmetry is the vertical line that passes through the vertex point. Now, if you'll notice, every point is reflected across this line. So we see this is 1 away, as is this one. This one is 2 away, as is this one. So it's a line of reflection. It's creating a mirror image on both sides. So the axis of symmetry, being a vertical line, will have the equation x equals. And if you'll notice, it's passing through x equals negative 1. Okay, so this is all the important information that we have from our graph. We're able to pull the vertex point, negative 1 and negative 3. We know the number on the outside will tell us if it's pointing up or down. We know the domain of an absolute value function is all the real numbers. The range will be restricted, however. So find your vertex point. If it's the lowest point on the graph, your range will be y is greater than or equal to. If it's the highest point, it'll be y is less than or equal to. And then our axis of symmetry is going to be our line of reflection. So it's a vertical line, therefore it will have the equation x equals. And since this one's passing through negative 1, it's x equals negative 1. Notice that the axis of symmetry value is the x value of your vertex point. The range value is the y value of your vertex point, and that should be the case. Now looking at number 2, we have f of x equals negative on the outside absolute value of x minus 3. So my vertex point here, my h value is 3. There is no k value. Remember, it's plus k. The only thing that you can add to get nothing is 0. So we'll have a vertex point at 3 and 0. Now my a value this time is -1, and what that's telling me is my graph will be upside down. So let's go to 3 and 0 and plot our vertex point. Now from here, we're going to use our slope of -1, and since it has to go down, I'm going to go down and to the right. Down 1, right 1, down 1, right 1. And then I'm going to reflect it across the axis of symmetry. Down 1, left 1. Okay, and so this one's going down. Once again, the domain of this function will be all real numbers because we're going all to the left and all to the right. My range is going to start right here at y equals 0, but it's going down this time, so that's going to be less than or equal to 0. My axis of symmetry is the vertical line that passes through the vertex point. So the equation of a vertical line is x equals, so this will be x equals 3. So once again, the axis of symmetry is the x value in the vertex. The range is the y value in the vertex. Okay, so let's look at these two graphs and let's point out two more pieces of information. Now, if you'll notice right here, my vertex point is the lowest part of the graph. When it's the lowest part of the graph, we call that a minimum value. Here, my vertex point is the highest point in the graph. When that happens, we call it a maximum value. Okay, so work out the rest of these problems. You have 1 through 12, and then we'll go from there.